This is what happens when you burn a mixture of zinc and sulfur. It makes something called zinc sulfide, which can be used to make glow-in-the-dark powder. Making it this way is fun, but the quality is usually garbage, and this stuff won't glow. To make stuff that actually works, it's a much more difficult process, and a little while ago, I was able to make some. I did this for a video on my main channel, and I also used it to make a weird, creepy baby thing. Today, I'm going to be showing you the classic barking dog experiment that I did a while ago on my main channel. To do this, I just have to fill a tall cylinder with nitrous oxide gas, which is the same thing that they use at the dentist. Then after that, I can add a few drops of a solvent called carbon disulfide. Now I just need to cover the top and shake it around a bit. I should now have a mixture of the nitrous and the carbon disulfide, and all I have to do is light it on fire. A while ago, I made all this scary bromine in my parents' garage, and now I've decided that I want to throw some aluminum into it. This is one of my favorite reactions, and the last time that I did it was probably over 6 years ago. Now with a bunch of it in a test tube, I just have to drop in some aluminum foil and wait for it to get started. At the bottom, I'm left with a bunch of dirty aluminum bromide salt and a small ball of aluminum metal. I really wanted this metal ball, and after waiting about 10 minutes, it shouldn't be as hot anymore. Now what I have to do is try and carefully get it out of the tube. To clean it up, I just have to drop it into water, and all of the aluminum bromide almost instantly reacts. After a few minutes, I pulled it out, and I'm left with a nice little metal ball. A few days ago, I bought some strawberries, but they tasted awful. So instead of eating them, I'm gonna pull out their DNA. To get started, I first need to make a salty soap solution. So into a beaker, I added about 180 ml of water, followed by 20 milliliters of dish soap, and roughly a teaspoon of salt. After mixing it around for a bit, it should be good, and I'll temporarily put this on the side. What I need next are the strawberries, and I picked out 10 of the biggest ones. Now, I'm just going to put them all into a plastic bag and carefully crush them. To all this strawberry goo, I now need to add the salty soap solution that I made before. It doesn't look like too much is happening, but the soap is tearing apart the cells of the strawberries and releasing the DNA. After mushing this around for a few minutes, it looks like it's ready, and the next step is to filter off all the solid stuff. This is going to take a while though, so I'll come back to it in a few hours. I ended up leaving it overnight, and now in the morning, I have this nice strawberry extract. I'm just going to go ahead and pour it all back into a beaker, and on top of it, I'll add some ice-cold isopropyl alcohol. The moment that it's added, it gets a bit cloudy, and some stringy stuff starts appearing. This is actually all the DNA, and it looks a little grosser than I expected. It feels super slimy and kind of nasty, but I think that's mostly from all the soap. Either way, it's crazy that just in my hand right here, I'm holding the genetic code of life. So I've decided to do one of my favorite reactions, and the first thing I need is some sulfur. I'll just add about 20 grams to a little container. On top of this, I also need to add some powdered iron metal, and I measured out about 35 grams. This mixture can be a bit unstable, and stirring it normally can sometimes cause it to go off. So instead, I'll just carefully shake it around until it looks evenly mixed. It was eventually looking pretty good, so I dumped it all out, and I spread it out as evenly as possible. At this point, it's basically ready, and I just have to light it on fire. The classic way to do this is by touching it with a hot glass rod, but I apparently didn't heat it up enough, and it failed. So this time, I made sure to heat it until it was red hot, and on the verge of melting. It almost immediately liquefies the sulfur, which then reacts with the iron, and this generates a lot of heat. It's enough to keep the reaction going, and it goes until it all burns. When it's done, and after it's cooled down, I'm left with a large chunk of iron sulfide, which I'm sure I'll find something to do with.